So we'll start with the Earth, actually. Before we even get to the sky, I want to start talking about the Earth a little bit. Now, the Earth is also a sphere. Now, the Earth really is, the surface of the Earth, it really is a sphere. Even though sky doesn't really exist, the Earth actually does exist, right? The Earth does exist. I mean, I can feel the Earth. And if you hit me with a rock, I'll feel it, right? That's for sure. That's a sign that the Earth exists, all right? And so now the sky has the Earth right smack in the middle of it. So this Earth is in the middle of the sky. So I'm going to go over the Earth right now and then talk about the Earth and see what we got here. So the Earth is pretty big. There's the Earth. And I'm going to put this line here that will represent the equator of the Earth. So the equator of the Earth divides the Earth into two halves. We say the northern half is called the northern hemisphere. So this is the northern hemisphere of the Earth. This is the southern hemisphere of the Earth. And so every sphere has two hemispheres. That means a half a sphere. So this is a half a sphere, southern hemisphere. That's where Australia is. This is northern hemisphere, where me and you are sitting right now. Now the Earth, we said, spins. So it has an axis, we say. This axis doesn't exist. This is imaginary. And so the spinning happens counterclockwise, like this. If you watch it from the North Pole, so if you put your eyeball here, and here's your eyeball, and you're watching the Earth itself with an eyeball. Can you guys see the eyeball, or do I need to move the camera a little higher up? Let me move the camera a little higher up. That's a little easier. All right. So watching it from the North Pole, it appears to be spinning counterclockwise. We talked about clockwise and counterclockwise. We said that just look at a clock with a second-hand clock, and the direction that it moves is clockwise. The opposite direction is counterclockwise. So this motion is counterclockwise. Most all objects in the solar system have the same beginning, so we all rotate the same direction. We all became planets in the sun from the same cloud of gas, and so we all have the same rotation. Now, as the Earth rotates, we see things rise and set. If you happen to be on this side of the world and the sun is on this side of the world, you'll be at nighttime. As the Earth rotates, pretty soon you'll see the sun. The Earth rotates from the ocean towards El Cajon, which means from west towards the east. And so the first place on Earth that, sees the sun, we say is Japan, because Japan is farthest east in Asia. So people in Japan will see the sun first. It's called the land of the rising sun. Then we see that the Chinese will see it then. And after Chinese, then people in Afghanistan and India will see it next. Then people in the Middle East, and then we go Europe, and then Atlantic Ocean. Then people in the United States, and then people in Hawaii. And then back to Japan again, right? And so the only reason that the sun rises, another illusion, is because the Earth is rotating. Not because the sun actually rises. Nothing rises except airplanes, right? And so the moon, the sun, the stars all rise. If you ever get a chance to relax, go outside at night and just watch the eastern horizon. Everything rises in the eastern horizon and then sets in the western horizon. Why? Because the Earth is rotating from west towards the east. So things appear to be rising in the east, and then they set in the west. So here's the Earth itself. I have a little model of the Earth, right? So we're talking about this Earth here. So we say the Earth is rotating this way, right? So the rotation of the Earth is this way. All right, so now we have some lines on the Earth, so we can find the places on the Earth, like your Google map. Well, we use the Google map, it's very easy, but we should also understand how this Google map works. So we have these lines on the Earth, and these lines are called latitude and longitude. I'm going to write that down, called latitude, and longitude, latitude and longitude. And latitude is how far north and south of the equator you are. That's it, right? So the equator we say is 0 degrees, and then you go north, right? 90 degrees north, and you go 90 degrees south. And so it's just north and south, basically. Whereas longitude is east and west. Now here, there's also a 0 degrees, and then you go east, and you go west. You go west. So longitude is east and west, and latitude is north and south. All right, so I'm going to draw the lines of what we call latitude first. It's not going to be very pretty. It's not very easy to draw these lines. So we say this is 0 degrees, and it's not north or south. When you move towards the North Pole of the Earth, which happens to be at the end of the axis here, you say this is the North Pole, this is the South Pole. Then your latitude increases towards the pole until you get to 90 degrees. So 90 degrees is at the North Pole, right? That's 90 degrees. And south would be 90 degrees south. So 90 degrees north to 90 degrees south. And so we say this line here is 10 degrees north. And this line goes all the way around the Earth, right? Like this. So it goes all the way around the Earth, like that. So everybody that lives on that line happens to be 10 degrees north. So we go, okay, then we draw another one at 20 degrees north. So here's 20 degrees north. And then 30 degrees north, 40 degrees north, 50, 60, 70, 80, and then 90 degrees north, like that. So it'd be like this. I'm sorry if it's not so pretty, but you know, it is what it is. Like that, right? So these are the latitude lines up and down. And then if you go south, same thing, except this would be south. So this would be 10 degrees south, 20 degrees south, 30 degrees south, all the way to 90 degrees south. Now San Diego happens to be at 32.5 degrees south, north, right? So San Diego happens to be about 30 degrees north. So San Diego has latitude. Normally we write down latitude with the LAT, lat. And so we say latitude of San Diego is 32 degrees, 32.5 degrees north. That means that me and you live here. So we live here, it'd be 0 degrees, 10, 20, 32.5 degrees north would be over here. That's my position on Earth, like that. So there you have it. That's my position. Any questions about latitude? You can get your microphone back on and ask a question if you like. And I'll look at your chat. Say Illuminati eye. The Illuminati eye for the nose, please indicate. All right, now.
Okay.
Yeah, question?
So does latitude like determine like weather? Like do both of them determine weather, or is it just latitude?
We'll get to weather later. The weather, there's a lot of things to consider when we talk about the weather. All right, so right now, let's not talk about the weather. Let's just talk about this thing we call the coordinates, right? The coordinates on Earth. So this is how we find our position. Latitude and longitude. That's how you find your pizza place. So your pizza place has some kind of a latitude on the Earth. Google Map knows exactly what that latitude is. That's how you get to Google Map. It knows where you live. It knows where your pizza place is. And your latitude changes as you go farther north or farther south. In fact, Google Map can give it to you within a few feet, right? You know exactly where your location is. Now, this is easy. Latitude is easy, right? What's not so easy is the longitude. Because latitude, we have the equator there. And the equator actually can be found fairly easily Because if you're at the equator of the Earth, something funny happens. You know how you flush your toilet? As you flush your toilet, you can watch the toilet, the water is rotating. And in the northern hemisphere, it rotates counterclockwise. In the southern hemisphere, it rotates clockwise. And if you're exactly at the equator, like in Panama, then it goes straight down, like woof, the water goes down. And so there's a guy in Panama, and for the tourist, he's got a little bathroom flusher on his back, and people can see the bathroom on his back, and he keeps flushing it. As he flushes it, you can see that the water goes poof down like that, and he makes money by doing that. Imagine making money by flushing a toilet every day. So that's what he does. All right, now, so latitude is easy because 0 is exactly at the equator of the Earth. All right, longitude is not so easy because it's either east or west. So, which direction do you go? Where do you decide the 0 is? So the 0 was decided politically, basically, and France used to be, Paris, France used to be 0 degrees until the French lost the war to the British, and now the British own the 0 degrees longitude. So the 0 degrees longitude happens to be at Greenwich, England. I don't know if you guys have heard about Greenwich, England, but Greenwich, England is 0 degrees longitude. So here it is. If we draw a line from the north to south like this, and because the lines on the surface of the sphere are always, curved, this is a curved line, this is the 0 degrees. So they say this is 0 degrees of the longitude now. All right, there's my 0 degrees now. That's my 0 degrees longitude. It's in Greenwich, England. Now, if I go east of that line, I'll be in the Eastern Hemisphere. If I go west of that line, I go into the Western Hemisphere. So remember, we said from 0 degrees for latitude, we go 90 degrees north and 90 degrees south. So we go 90 degrees north, all the way to 90 degrees south. Here for longitude, we're going 180 degrees east and 180 degrees west. So you go 180 degrees east and 180 degrees west. All right, so if you go to China, that will be in the Eastern Hemisphere. If you go to Middle East, that'll be in the Eastern Hemisphere. If you go to Russia, that'll be Eastern Hemisphere. If you go west of Greenwich, England, then you're in the Western Hemisphere. So we're in the Western Hemisphere. And so the longitude of San Diego is 117 degrees west of Greenwich, England. So we're at 117 degrees west and 32.5 degrees north. That's our coordinates on the Earth. That's San Diego, basically. If you go to Los Angeles, it's approximately the same longitude. I believe it's 116 degrees. And it's a little bit farther north. And so it'd be like, 33 degrees north instead of 32.5 degrees.